In this problem, we're working with a couple moment, and you'll remember that a couple moment is defined by two forces which have equal magnitude and opposite direction, and they're separated by some distance. We know that on this system, which is a pipe with some wrenches on it, we know that the magnitude of this couple moment is 400 Newton meters, and the question here is, what is the magnitude of F, the two forces there, F, that will give us this couple moment? So this is asking us to confront this idea of what a couple moment is and how to mathematically describe it. Well, it turns out this problem is actually pretty straightforward if we think of this in a really sort of simplistic way. So let's go ahead and write an approach which explains that. So step one in our approach is going to be to find the distance from B to A, and I'll explain in a moment why that is the important quantity. And then in step two, we're going to use F times D equals to 400 Newton meters to go ahead and solve for the magnitude F. Now, before we go ahead and do any math, let me just take an aside here to sort of describe why this is an important thing to do. We know that for a couple moments, the key quantity is that distance between the points of application of the two forces. Remember that couple moments are sort of these free vectors that no matter which point we're looking at, whether it's, say, point O or some other point on the structure, say there or there, the moment that is occurring at those points, it's all the same because a couple moment is sort of a free vector that operates at all of these different points. And the reason it's a free vector is because it doesn't matter, the point from which we make the moment calculation doesn't matter because of the equal and opposite nature of the forces. So let me erase my black lines here so I can make some room. What happens is that the couple moment is defined only by the distance between the two forces. So really it's this distance right here that we're going to call D. That is the important one. And so what we really need to do is just find that distance. And so the distance from A to B is the important one, and that's what step one is all about. So let's go ahead and do step one. Find the distance from B to A. We know that points A and B are both in the same plane, and so this really reduces down to just a little bit of trigonometry. There's not really an awful lot to it. So if I extend this line right here, and then I extend this line over here, what we've got now is a triangle in the plane. That is a right triangle. There is my right angle right there. And so it really just amounts to finding these distances. So this distance right here is going to be 150 plus 200, that's 350. That's going to have units of millimeters. And then this distance right here is really just going to be 400 minus 200, so that's 200. And again, units of millimeters. So what we're really looking at here is D is just equal to the square root of the sum of the squares, 0.35 meters squared plus 0.2 meters squared, square root. So this turns out to be 0.403 meters is our distance D. Now that we have that distance, the couple moment calculation actually is very straightforward. So in step two, we use F times D equals 400 Newton meters to solve for the force F. All right, so F times D, which is 0.403 meters, is equal to 400 Newton meters. So this means that F turns out to be 992.6 newtons. And there is your answer. Let's review what we did. Back here, this whole problem is about couple moments. And with couple moments, the key parameter that we need to know is the distance between the application points of the force. In this case, those points are labeled as A and B, and I am calling that distance D. So by using a little bit of trigonometry on the figure, we could figure out what D was, propagate that through to the solution, and find out that F is equal to 992.6 newtons.